we believe that 80% of ETHS staff and students can tell the difference between gluten-free and gluten brownies.
For our project design, we made a batch of gluten-free brownies and gluten brownies. We cut them up into fairly equally sized cubes and put one gluten-free cube and one gluten cube on a paper napkin. We told our customers to try them both and tell us which one is gluten or gluten-free. And we also asked them to let us know if they were just guessing or if they were actually confident about their answer.
I'm just supposed to
Hey Justin, please try these two brownies and tell us which has gluten and which one has no gluten.
Which one has gluten and which one doesn't?
Yes.
Maddie just keeps giving me these looks of pure hate.
You guys got big piece of brownie.
Yeah, you chew that brownie.
Nothing else I can do.
Chew it.
I'm not ready for this scientific experience.
I'm not ready at all.
Fuck up.
The first one I ate had gluten.
He's
No,
wrong!
No gluten. I meant no gluten.
You sure?
I promise
Aye.
you no gluten.
After further investigation, we have come to the conclusion that there is not enough evidence to prove our claim false.
Our experiment yielded a 27 out of 30 success rate, which means that 27 out of 30 people successfully identified which brownie was gluten-free and which one had gluten in it. Using my TI-84 Plus Texas Instruments calculator, I utilized the binomial CDF function. What I did was I did 1 minus binomial CDF out of 30 trials, the p-value, the probability value, as 0.8, which is what our claim predicted, and our x-value was 26 because we wanted to see what would be 27, 28, 29, or 30. Our result was 12.3%. The probability that 27, 28, 29, or 30 people would predict correctly is 12.3%. 12.3% is a high enough percent that we do not believe that our claim is false. If our percent was 5% or less for 27, 28, 29, or 30 people, then we would believe that our claim is false. But since we had 12.3%, we do not believe it's false. Here are a few things that we could have and should have done differently.
We could have made the experiment blind, not allowing our customers to see which brownie was gluten and which was gluten-free.
We could have made or bought better tasting gluten-free brownies so that it wouldn't have been as obvious which ones had gluten and which ones didn't have gluten, which might have led to a different number of successes.
We should not have let our subjects see the previous person's reaction, because that might have helped them predict which one is correct.
The qualitative observations we made were male versus female, adult versus child, and which type of brownie they selected to eat first.
For experimental result, we tested real humans and found the real-life probability of people who can detect gluten in brownies. We used theoretical probability to predict that 80% of people would be able to detect gluten. Through our simulation of 200 trials with an 80% success rate, we discovered that 30% of those trials had at least 27 successes. Our experimental result reinforced our prediction immediately, while our simulation reinforced it long-term and more permanently.
After further investigation, we have realized that our claim is actually, I don't know, what am I saying? Using my TI-84 Plus Texas... So, the probability that someone would guess 20... Nope. Brandon, on Tinder.
Is this you wrestling?
That's my Tinder girl.
Can you start over, dude?
Another factor that we could have... the previous person reacted.
The qualitative Stop, Mason.
Oh my God.
The qualitative what?
Observation.
There we go. Ready.
We made.
According to our